Welcome back to the Electronics Inside. I'm David, and let me open with a very quick public service announcement. Everybody knows the best formats are analog and come on 12-inch discs. Oh yes! The risk of really showing my age here, I'm going to do a bit of background just so everybody's at the same level. So I think everybody should be reasonably familiar with a Blu-ray format, regardless of whether it's got video or other data on it. That's about 60 gigabytes for the same physical form factor as DVDs that came before it. Now DVDs are up to, I think it's 8.9 gig dual layer or something along those lines. And of course DVDs were modelled on the same physical form factor as CDs. Now it's quite obvious that the physical form factor has continued even when technology took an upwards trajectory, and physically to look at, there's really not a lot in it, and you know, the only difference is really the size of the pits and a few other technicalities, but in reality it's the wavelength of laser needed to read these discs. So CD, DVD, Blu-ray, fundamentally the same thing. And it's not the first time that this has happened. I mean, 12-inch vinyl in some way, shape or form has been around for, well, let's just say a very long time. And it's an analog physical method of storing data where the grooves in this record, this disc, are physically engraved and it's read out with a needle, and those wobbles in the lines, those vibrations, are a physical representation of the data stored. In this case, an audio track. Now it makes sense that once you've got a very well established medium like vinyl records, that you'd want to maintain that physical relationship and see that as your target. So in 1978, when LaserDiscs came out, I'd say that made a lot of sense. Okay, at the risk of being contentious right from the bat, this is technically an analog format. So this has a representation on the disc read by a laser that represents the wave that is demodulated from FM to produce your TV signal. Later discs use PCM for the audio track, which is pretty much the same as CD audio, but the video on these was always analog. I don't think I agree. This is going to get nasty quickly. Okay, so the disc itself is still made up of binary data. You can only have two states for the video track. That's a 0 and a 1. Now the 0 and a 1 are not encoded binary, but they are representative of an FM modulated wave that represents the video track, but it's still recorded as 0s and 1s. To me, that makes it digital. I appreciate it's not like PCM encoding or a digital file in the way we think of video encoding. It's not like MPEG 1 or MPEG 2 like a DVD, or H.264 like a Blu-ray, but it's an analog wave represented by digital data going between 0 and 1. That makes me think it's analog? Oh, I don't know. I'm sure everyone's going to complain, so head over to the Element 14 community, link in the description below the video. Let me know what you think. So as much as I would love to sit here all night and discuss the differences between the various versions of LaserDisc and the petty differences between analog and digital and where the threshold is, I'm not sure you've come here to see that. So, let's tear down a LaserDisc player. This particular one is the CLD V202 from Pioneer. It's decidedly geared up towards karaoke and is very late in the life cycle of LaserDiscs. It's sold to me as spares and repairs. Don't think this is going to have belts in it, but equally that's kind of an obvious place to start. I'm not particularly looking to restore this because, let's face it, who has LaserDiscs that haven't suffered from disc rot yet? So let's get into it. It's got that classic VCR stroke audio separates form factor that everything had at the time. Whew. You kind of forget that it's going to have a whacking great CD tray with various lasers on it. Okay, interesting. This whole loom comes back to an awful lot of processing. Now these headers are very reminiscent of the audio headers you have on PC motherboards, so it wouldn't surprise me if these were some, when they're individual and unscreened, so I don't think you would pass signals between boards unscreened, untwisted. They may be higher quality signals, we shall see. So on the silkscreen on the back, they actually put schematics in, or schematic symbols in for where you should have diodes, where you should have capacitors, where you should have resistors. I've not seen that before, that's awesome. Okay, next layer down, I think is actually this daughter board at the back. For anybody that doesn't know, this is a SCART connector. Now SCART originated in France and as such has is an initialism for something that I'm not going to try and pronounce. But take my word for it, it's like Syndicate of Radio and Television Accessories, something like that. But basically it can handle input and output, audio and video, but not only handles component, but it will also handle composite on the same connector. 21 pins, and also had a 12 volt signal switchover contact, if I remember rightly. Awesome little thing, and was great before HDMI. Big chunky, but very, very flexible. Now I understand early LaserDisc players didn't actually have diode lasers in them, they actually had chemical lasers in them, which to me these days sounds incredibly frightening, but I guess it was the technology available at the time. Certainly sounds like a single point of failure to me. Can't imagine replacing the cost of the laser, the chemical laser in these would have been anything other than prohibitive. Those two boards look very sandwiched. Very decent build quality. I guess this is a semi-commercial device. It wasn't a home device, so I hope it was suitably costed. Oh goodness me! Look at the connectors on here. Slightly weird configuration here where there's a board like stuffed down in an angle. Don't know what that's about. I suggest this would be an LED backlit display. I think this is too modern to have a vacuum fluorescent display. See, I always like these huge kind of electromechanical assemblies for clever handling. And I always think, oh, there should be like 30 switches and different motors and sequences and stepper motors and servos. And when you get into it, it's just a really clever single motor driving a clever like clockwork mechanism. So let's have a look at what the LaserDisc is going to show us. Oh, we could be in luck. Okay, so here is eject. There you go. Ooh. Now looking at that really shows how this disc would have fitted in. That should be free to spin. Excellent. So the carriage is then free to pan along, search for the disc and read it. You've got the laser diode here, which of course is on its little vibration mounted assembly. And also you've got a little diode here, which I'm pretty sure would have been shining up to try and read as quickly as possible and as roughly as possible if it was a laser disc or a CD inserted in the mechanism. So it's interesting with the disc tray out, you can see how much is actually in this. And well, actually quite a lot. Okay, next board out, no outputs. And other than that, these two boards are actually soldered together. So I would have said there's not enough decoding going on these two boards unless you're actually sending video signal through these ribbons, which I just wouldn't have thought you would. Poking around on this main board, I can already see a nice big dip IC here, a lot of connectors on there, and there is an even bigger one tucked under the back edge of this tray. Now those two on this board make me think they're probably dedicated ICs, something specific to doing the demodulation for that digital-esque signal. Can now start to see some more of this mechanism with these beautiful cam traces. You've got the spindle here with large motor underneath. LaserDiscs, I think they were span like 3,000. Oh, I can't remember the speed of the disc, but I remember seeing it and thinking that's not a slow revolution. Over here, the board with the transformer on it seems like a brave place to put a connector. Oh man, when these ribbons go under the optical assembly, that's just ridiculous. The fact that this power board has got some ribbons pre-soldered to it with connectors on the far end, other ribbons with connectors on this end, there's very little consistency, and that would have made this a very challenging build. Okay, more drive mechanism. So CD tray, optical carriage, eject mechanism, spindle. But how do you take it apart? Or do you not? Do you just take the whole thing out in one go? It's always a possibility. Okay, there's a better look at that other big IC that I could see. Okay, that's a little feedback daughter board. It's got 3 tiny little surface mount switches, very low actuation force. But you see they've just got all these corresponding levers in the physical mechanism. So at some point in its travel, I'm imagining each of these arms is going to actuate and press one of those buttons. There you go. So on the underside of the spindle motor, there's a perforated wheel, which is very reminiscent of old pre-optical mice, which is going to be purely feeding back the rotation speed of the disc in real time. With a decent degree of accuracy, there's probably 40 notches in the wheel, and it's just going to go back to this little light gate on this little plastic mechanism here. There you go. Tiny little light gate, just keeping an eye on the speed of the rotating disc, which I haven't said yet is important because LaserDiscs came in 3 different flavours: constant angular velocity, constant linear velocity, and constant angular acceleration. I'd quite like to leave this entire assembly intact because, well, it's kind of cool. Oh, look at the size of that spindle motor. That's a lot of energy to get these discs spinning at the right speed, isn't it? Sorry, just a note on how this is manufactured. I mean, I'm not an expert on injection moulding or anything, but this to me looks like they pressed the metal piece, put the metal piece in the injection mould, and then over-moulded all these plastic components. Because you can see that they all sort of run together. Alright, there's a few of them have aged and cracked now, but you can imagine that's because they injected the plastic in one point and wanted it to run all over. And actually, there's no way for them to come out. So that's a really cool manufacturing technique that produces, I imagine, really precise and hard-wearing parts, where you've got plastic where you need it, metal where you don't, but in a really precise way. That's super cool. I don't think we've seen that anywhere on any of our teardowns so far. Okay. There we go. She's out. Nothing but a big lump of metal. Anyway, before we get too carried away looking in detail, should we have a bit more of a look at what went to making this front panel? Don't imagine there's a lot going on here. Probably display driver, maybe some multiplexers. We shall see. Again, this seems like a really unnecessarily complicated way of making this. There is 1, 2, 3, 4, 5, 6, 7, 8 separate boards here that I can see. I feel like the front could have been really simplified. Oh, a 9th board just for good measure. Oh, well, I take back what I said about this being LED. That actually could be a vacuum fluorescent. That entire module is under vacuum. You can see the little nipple here where they vacuumed it out and melted that and sealed it. So that's a vacuum fluorescent display. 8, 9. Yeah, 9. 9 boards. I feel like that really could have been value engineered down to 2. Now the only thing I'm feeling quite comforted by at this point is, do you remember this connector right at the beginning that had all the cables twisted, and I said it kind of looks like the audio CD input inside a PC? Well, that actually connected down here to the analog inputs. So I'm feeling slightly vindicated that I saw that twisted cores and sort of went, yeah, audio. Makes me feel mildly good about myself. Right, let's have a super quick scooch through some of these ICs. We'll go through the more interesting stuff. So, main board, I'll do my best to remember these all. I'm pretty sure this is a microcontroller. It's got 7004 2MB 106 on it. I'm pretty sure this is going to be the microcontroller that sort of runs the show. It's going to interface with the motors, the electronics, the input and output. Up here we've got HA12127ANT. which is an FM demodulator. So basically this is going to be taking that digital or analog FM signal off of the LaserDisc and converting it into the signals that we actually need. You can see the high quality components they've got lined up either side of it just to cope with that. Over here we've got a Sony CXA 10815, which would have been used for the audio decoding. That's a audio FM demodulator, and even you can see the bodge wire, which I hadn't spotted earlier, between one of the legs on there and one of the traces. On the reverse side of this board, we've got a Philips digital to analog converter, and this is the Sony CXD2500BQ, which is a CD audio decoder. So that is going to be taking the PCM audio and decoding it. And then over here you have, this is your audio amplifier. So right here you've got everything you need to kind of make it work in a basic kind of way. And of course that's not the whole show, because you've got all of these other boards which basically handle the country or region specific output. Now a lot of this is just analog TTL amplification and signal handling, but up here you've also got a CMOS chip. So that's going to store some presets that feed back out to these ICs. And that is largely it. I mean, the only other thing which I'd like to kind of draw attention to is stuffed down the back of this poor vacuum display. You've got a very, very large dip IC of some kind, and let's be honest, that's not going to be anything else other than vacuum fluorescent display driver. Okay, first off, I think I owe this device an apology. All the way through I've been slightly critical, saying that I think it could probably do better, could have used multi-layer PCBs, could have all the sorts of things. I never thought to actually check what date it was manufactured, and I've just looked it up. It turns out this came out in 1990, so alright, there definitely were multi-layer PCBs around in 1990, but I feel slightly less critical of it all the same. And in terms of LaserDiscs and the technology, let's face it, in 1978, can you imagine leaving a shop with one of these? How futuristic it would have felt? I know they're a bit of a non-starter as a format. I know that in a world where home video recording was becoming a big thing, that a static format like this just didn't cut it. But they're awesome, and I hope you agree with me. If not, you're wrong. Either way, I hope you've enjoyed this teardown. If you have an idea for a teardown you'd like to see, head over to the Element 14 community, look me up. I'm AIM531016, we'll put a link in the description. Thank you for joining me. I'll see you next time. Of course, you know it used to be in a pub for karaoke when there's broken glass inside it.